Hello. Hey everyone. My name is Yunzhong. I'm the co-founder of Kaito AI. So a little bit about Kaito. At Kaito, basically, we're building this search engine for Web3 where we collect all the discussions, all the rumors, and all the unstructured data, index them, and then generating insights for trading and marketing, etc. And then prior to that, I spent 6 years at Meta, where I managed a team of AI researchers and ML engineers to basically build the foundational models behind Meta's search engines. So today, I want to talk about some of the exciting trends that LLM is bringing to search and machine learning and workflows in general. So first, I think I keep hearing this myth where people are saying, hey, big techs are going to be supercharged with LLM, with all the army race, since they have all the compute and all the user data. People are going to get more powerful, big tech are going to dominate. So I think I won't make any judgment here. I'll leave that judgment to you guys. But I think it will be interesting to understand exactly how LLMs are going to help with machine learning and data science in general, except for all the chatbot, basically more chatbots that we've seen. So what's happening behind the scene, and what are the interesting things that's happening out there? So first, I want to break it down into how exactly do people utilize LLMs in search and recommendation engines, other than just new applications like chatbot. What the benefits do they bring? And then what are the difference in perspectives if you're working for a big tech or a startup? So maybe let me go over the first example. That will be embedding models. So actually, the trend of foundational models empowering all the basic machine learning applications happened a long time ago, before ChatGPT. And that's when the term foundation model come out. When we talk about large model back then, there was 500 million parameter models, like BERT. And then, so let me just give you an example. So traditionally, in search engines, it's difficult to do keyword matches. For example, if I search for cat, and then there's a document that contains the word kitty, you will need a lot of traditional wisdom, machine learning, NLP to be able to do synonym matches and all that. And then, so with the LLM, there's this new technology where you can just encode the query and the document into some neural representations, and then you just find similarities, do a similarity search in this latent space, a vector space. And how LLM helps in this case is that those models are pre-trained and large scale of content data, which means that it has the ability to generalize and understand, possess some sort of common sense in the text space in general. So that helps with the common sense matchings like synonyms and all that. And then, I think some of the work started as early as 2019, 2020, and then that was some of the work we published. Basically, we introduced the first embedding model, and then extended to multi-model to process the image, and then doing early fusion of multi-model and all that. I won't go into too much details, but just want to highlight. So this is one area that LLMs are working behind the scene, where it's actually taking all the pre-trained knowledge from massive amount of text data, and then generating this neural representation that does not require lengthy autoregressive inference, such that it can function really well in all kinds of machine learning systems. And this trend has been going on for years, basically how you are able to leverage common sense from those large models in all kinds of machine learning applications. And then this is very different from many older technology based on ID-based embeddings, where sometimes it's more of a memorization rather than generalization. And then some of the exciting trend with the new, even larger scale LLMs, especially the decoder-styled autoregressive models, is that now they are able to generate and synthesize data. So here I want to share one interesting work done by some of my ex-colleagues. Basically, people are able to get to the state-of-the-art embedding models without having extra data. So what they do, actually, they just synthesize a bunch of data for different domain-specific problems with the more expensive models, and then they use that data to train the embedding model so that they can perform fast inference in all the traditional machine learning applications. And that's proven very helpful. And then actually from a startup perspective, this is a good news, because for us at Kaito AI, we managed to build a bunch of cool machine learning applications without having a lot of user data, because we can just define the problem, synthesize data, and then train some models. So this leads to the new paradigm that I want to introduce. Basically, this is called the generative machine learning engineering. So in traditional workflow of machine learning engineering, people collect the data, train the model, evaluate offline, and then bring it online for A/B testing. And this suits well for big tech with a lot of data, and then significant amount of traffic for A/B testing. But then it possesses problems for startups like us. Like we don't have that much of user data. Like how are we able to build comparable models, even better models in a specific domain, for example, Web3 search, compared to the big techs? So basically, we're able to leverage this common sense knowledge and reasoning ability from LLMs by collecting samples, generating prompts, and then synthesize domain-specific data based on some seed information, and then perform SFT, like parameter-efficient training, and then maybe just use that data to train a smaller model and integrate it into like the faster, low-cost traditional machine learning system, such that people don't feel the LLMs, but actually like there's all the LLMs working behind the scene. So that's why I think that's one interesting example where LLMs is really revolutionizing the field, but sometimes in areas where people cannot see because like they're not generating new product experience, but rather they're empowering existing machine learning applications. And then, for example, sometimes you can even just prompt. If you have a classification problem, now you can just prompt. So let me give you a few examples that we did. So at Kaito AI, we managed to build this really cool application, the narrative trackers. Basically, every day we look at like hundreds of millions of social media data from Twitter, Discord, Telegram, and then we perform large-scale data mining, basically cluster those data, and then generating new narratives, like basically things that people are talking about. For example, like GameFi, L2, like AI agent, and then we compare to all the previous data we might have this fully automated pipeline to generate new stories, and then we classify all the content into those stories, and then we are able to get this nice chart on the narrative breakdown with all the things happening in the Web3 space. And it turns out to be a good indicator of trade signals. So likewise for sentiment, like sentiment analysis has been like a problem for years in the NLP space. And then there are like a bunch of specialized models for that. And most of them require large amounts of data. For us, we are facing this more interesting sentiment analysis problem where we're really looking for things that's leading to like trade indications. For example, sometimes if you say, hey, I'm really happy and I bought some Bitcoin, it doesn't really matter. You really want to find the positive sentiment towards a specific project. I think that applies to traditional finance too. That's a more interesting sentiment analysis problem with less data that people collect, because the people in the academia, they generally, like they miss the sentiment in terms of trading and financial implications are like underrepresented in all the data sets from the academia. And then for us, we are able to bypass that problem without having to label a lot of data with this generative workflow where we can generate some seed information and then synthesize data and then train models and then use prompt and then do model distillation and all that. So that we're able to do this very nuanced analysis of trade sentiment using LLM at large scale with very low cost. And then, so given that there's a huge audience in the crypto space over there, I want to also mention some of the new interesting ways of data acquisition using LLM. So right now, I think the entire internet space is facing this problem, that the internet is becoming more and more closed. Because I think on one hand, like people start realizing how valuable data are. So then all the big players in the field, they start to close out their data. Like sometimes people even poison their data when they detect some automated data acquisition process. So this is a paradigm shift. Unfortunately, the internet is getting more and more closed. And then, so data acquisition start getting harder. And then I think one way to tackle that problem is really through the community and crowdsourced intelligence. Basically, if the community can define like what data that they're interested in, and then we let every single user to contribute to that data, and not to the contribution of just the raw data, but also the understanding of the data, for example, the sentiment. And what's better if the community can define what are the most valuable aspect of data that they want to acquire. That would be great. But then in order to scale that approach, we really needed an automated approach. And then that's why we think like this is something that blockchain can help. because blockchain basically solves that problem. This is like a permissionless system where everyone can contribute. And then the problem that you need to solve is to identify the bad actors, incentivize desired behaviors. And then you want to do that fully automated, so it wouldn't be scalable if you have some human labelers sitting out there to spot check all the data, right? So then, so at Kaito, we're running this really interesting social experiment where we try to decentralize the entire process of data acquisition, data understanding, content understanding, and data indexing in a decentralized way. So this project is called the Open Kaito. It's currently, we don't build our own blockchain and all that. It's powered by the BitTensor network. So here's how it works. So basically, you want to decompose the problem of data acquisition and content understanding into like mining and validation scheme. So it's similar to like the NP problem. Like, for example, you have a polynomial checker that's really easy. So people can check whether this data is trustworthy, whether this piece of content understanding is correct, using like a fairly simple method, automated, and people can reach consensus. And then you leave the harder problem, for example, like the factorization of integers to the people who are working and get incentivized by this economy. So this is similar. I think this is a great analogy for the NP hardness in computer science. And then, so the interesting problem is how do you validate the process of permissionless data acquisition and content understanding? Because there's no way that people can generate fake data. Like people can do like using very low-cost model to do bad sentiment analysis, and how do you able to check? And this is, I think, excitingly, this is how LLM can help. Because if you think about it this way, for example, if I want to collect all the high-quality cat image from the internet, right? And then, so in order to do that, we need every single person to collect cat image and look at the cat image to see whether it's good or not. So there's no way that you can do that, even with LLM, because there's so much data, so much work to be done. But then once people uploaded that data, saying, hey, this is an image of a cat, we can spot check those answers with LLM. And LLM, they possess this level of general intelligence that can be instructed to do all kinds of verifications. So that is somewhat like a model distillation. Basically, you are leveraging the blockchain network to distill the knowledge of LLM to verify the data. And then in order to incentivize large-scale acquisition, understanding, and indexing of the data from the internet. So we managed to run this social experiment on the BitTensor network. And then here's an example of how we basically just defined the problem of getting some high-quality Discord data so that it can be indexed and made searchable. And then within days, like the network, incentivized all the workers there to generate great data for us. And this is measured by the traditional, like the DCG score from search engine. So then you can see, this is the first time in my career I was able to optimize DCG score for a search engine without actually running any machine learning myself. I just defined the problem, and then the network solved that problem for us. And then, so how does that economy work, right? How does that reward mechanism work? So ethically, it works, it really forms a closed circle. Basically, when the community are there, like they're defining the problem, defining the value, generating the value. And then so everything in the future is going to be powered by the community. People define the problem, solve the problem, derive economic values from it. And I think that is the way out in order to solve like the problem of the closed internet. Okay, so that's the end of my presentation, and I'm out there in the conference. If you have anything you want to discuss, feel free to just come here and talk to me. Thanks.